Folks, we have to have a chat. I've been seeing so much abuse of exec and eval in Python lately, it's gotta stop. For those of you who are penning comments already about virtualization and using sandbox environments, hold off. I'm not talking to you guys are fine, but for everybody else, this abuse of these functions is not okay, and I'm going to show you why in this tutorial. So I wanted to make a tutorial about how just ridiculously awful the eval command is. And I'm going to do that the same way I did in MATLAB, which is by making a simple graphing calculator. To start off my video, I should probably explain what eval and exec actually do. These are two functions which can do basically anything. The main difference between them is in their use case. So evaluate evaluates an expression. So for example, I can evaluate the result of 5 plus 5, and you'll notice it's getting returned. So I actually get the value of the thing that I put into eval back out. On the other hand, exec, if I do that, doesn't actually return the result. It actually executes whatever's put into it. So if you think about it, all of Python could just be replaced by the exec command. It's essentially run the thing that I give you as if it's a script. As you can imagine, with great power comes great responsibility. These things can do very literally anything. So for an example of how ridiculous this is, let's, for example, evaluate a directory that we're in. So if I do os.lister, okay, listdir, I can get what's in my current working directory. Worse than this, though, if I want to, for example, delete a directory, rmdir, I can actually delete, for example, my virtual environment. So if I do eval, that would delete the virtual environment that I'm running in. I don't want to do that because, well, that would kind of disable my virtual environment, but I can almost immediately damage my environment that I'm running Python in, just trivially. So this is a bit of an issue because I have almost complete control over the computer using these two commands. The difficulty is these are really useful commands. So to give you an example of how useful they are, like, let's look at a simple graphing calculator I made. This is unbelievably simple. I throw a function I want to plot in, I click plot, and hey, I've got a plot window. Yay! I can also set options with it. So for example, I can create a title, and I can make an x-axis and a y-axis. And everything's totally happy. So the difficulty with this is, the way I did this, if you look in my code, is I evaluate whatever's in the function box, and then I execute whatever's in the plot options box. The good news is that the eval function is slightly more limited than the execute function, but the bad news is both of these are way too powerful. I can do anything that I want with this. Like, really anything at all. Let's see how far we can actually kind of push this. So, for example, if I wanted to look at the current directory, I can print this out by doing something like os.lister. Here, I'm dependent on the fact that the OS package has been loaded into memory. It's possible, though, to do imports here as well. So let's see if we can actually explore the operating system. So os.change directory, and we will go to the C drive. Cool. Great. I am in the C directory, and we have a bunch of stuff there. I have recycling bin, a boot manager. Point is, I have read access, at least, to my entire computer at this point. So anyone who has control of this app is basically able to do anything that they want. For example, I can go ahead and explore the computer a little bit. Let's take a look at what users we have available. There's the user I seem to be using right now. So I can also, for example, go into my data sets. I seem to have a thing called junk, high cert junk, duck hunt. Take a quick little look-see at what's in high cert junk. Interesting. So let's see if I actually have the privileges necessary to delete some of this stuff. So I can do something like os.rmdir and go ahead and trash the junk folder. See if that works. If I run it twice, what you'll notice is the junk folder is no longer visible in the list. I was able to delete a folder off of my hard drive. Now, that folder wasn't a useful one because I'm not going to trash my computer for the sake of a YouTube video, but the point is I have read and write access to anything that this Python executable, the user running this Python executable does. And I can do more or less anything I want to this computer. This window lets me do whatever I want. And the underlying reason is that the exec function lets me do anything I want. It's an incredibly insecure function. In fact, there is no security. It just does what you tell it to with no double checking whatsoever. Now, the eval function is a little bit more secure in some sense, so let's take a look at that. While the exec function will evaluate whatever you put into it, it doesn't require that the output kind of do something, whereas the evaluation function is in fact performing a specific thing. It's evaluating an expression itself. So let's take a look at the eval function there. And so originally we were just plotting this function y equals x. So you'll note that I am setting this y equals the output of the eval function. So I have access to x here, and I can do more or less anything I want in here, but it does only get assigned to the y value at that point. So, for example, if I tried something like that, it wouldn't actually be able to set an equals value here because that isn't a valid expression. However, if I had a getter or a setter method, those would still do this. I wonder if I could do something like this, though. Yeah, that executed it. So I can put things here. In fact, I can embed the exec function inside the eval function. So it did immediately crash, but for example, I can have this print a variable or print something out to the screen. Let's pop this back up. Where'd it go? There it is. Exec print x. Ooh, is it? Oh, no, we managed to get it out. Okay, so I am able to do this. It does in fact print it out. It has some issues with plotting, but it does in fact execute it prior to that happening. Basically, no matter what you are doing with eval and exec, you're going to end up with something that is insecure, just fundamentally. You can, at the extreme ends, sandbox the environment, but if there's any way you can avoid using them in production code, you should. To kind of take this to kind of the logical extreme, because it's really inconvenient to work from the Python window itself. The ultimate goal of pretty much any attack like this is probably to gain access to an actual command prompt. And we can do that fairly straightforwardly. So what I can actually do is just do the os.system command. So for example, this should provide me with a command prompt, and has done so. I have access to a command prompt now. Because I was running this on PyCharm, this is in the PyCharm window though. So let's check what this behavior would be if I was running this outside of PyCharm. So if I was running this outside of the environment, which you could obviously do a lot of different ways, everything is still working. And if I go ahead and run the command prompt, it pops me out in the terminal. So let's say that I was in an environment which had locked down this terminal though. I would be able to use the start cmd command like so to actually pop up my own window here. So now I can have lots of them that I can do whatever I want with. So at this point, I obviously have complete control of the machine. I can do absolutely anything I want with it. So the question is, how do you prevent problems with this? Like, is Eval and Exec redeemable? And I think the short answer is no. You have some control options to make them less terrible, and we can look at that. So one of the things you can do, if I bring up my tutorial code, one of the options I have is I can limit the scope of the variables that are accessed. So if I do this, my code still functions. However, for instance, if I have another variable here, I'm not able to evaluate it. You see, it doesn't find the z value here, it only finds the x value. And the basic idea here is that you're able to restrict the namespace. However, doing this doesn't actually solve the fundamental issue that I can still execute whatever I want. So I still have access to the exec command via eval. In order to limit this, I would need to start hunting down ways of limiting what input I can put into these spaces. There's obviously, you have some options here, but it becomes a creativity battle. So for example, I can deliberately look for the cmd command and filter out attempts to use that. But as soon as somebody does that, well, now somebody is going to start coding in the integer values for the character arrays. Remember, I can do anything I want in here. So by limiting the scope, you might be in a position where you think that this is going to protect you. After all, my eval function only has access to a local variable. So for example, I no longer have access to the os command. So if I do os.system dir, if I do that, it doesn't run. Name os is not defined, and the reason is os is not a variable it has access to. That import is not available. The problem here is that I can still import os here. Now, if I do it like this, it's going to be confused because this isn't this isn't an expression. But if I put the whole thing into an exec block, I'm able to evaluate it just by doing something. If I put the whole thing into an exec block, though, and put appropriate quotes around it, I'm able to evaluate the directory still. So even though I have my local variables limited, it's still possible to do imports in principle. There really isn't a way to scrub the inputs here so thoroughly that it's impossible to escape from them. Certainly not a way that I would ever trust on my own machines. So as an example, I might deliberately filter out uses of the exec command. So I'm not allowed to run exec from inside exec, but somebody can work around this by just going ahead and importing the subprocess module. And you notice I can just import a module, right? I can do anything I want here. So how much of an arms race do you want with the person who is trying to break into your code? A much better option is not to use these functions at all. And if you must use them, you should use them in a sandboxed environment. So even if somebody had complete control, they wouldn't be able to do anything. And honestly, setting up an environment like that properly is way more work than almost any reasonable workaround for this. The truth is the best thing to do is not to use these functions at all. The basic issue and the primary difference between SQL injection attacks and Eval and Exec attacks is that Eval and Exec, their entire job is running code which has functions in it, right? You're writing this code to do things, whereas an SQL injection attack, usually that's actually just a string of data and you're attempting to convince it to run things. So in an SQL injection attack, all you have to do is avoid them from escaping from the string. Whereas if you're trying to prevent an eval or an execution attack, well, the code is supposed to run a function. At some point, you need that stuff in there. So how do you stop them from introducing a new function? You're basically in an arms race with the attacker at that point because your main tool, stopping them from doing anything to it, basically, is not available. So I'm not saying that it is strictly impossible to do, because I don't think it's strictly impossible to make this code secure. I just don't believe that you will. And if you're the type of person who can make your exec and eval things so secure that this won't happen, well, you're a better coder than I am. That's, I think, what it comes down to. The risk from playing with this is just so great. One thing I do want to address is something I've heard pretty frequently. It's okay if I use it in my code because no one else is ever going to use my code. Like, it's okay in my code, no one else is ever going to use my code. And this, I've heard this a lot over the years, like tons and tons and tons of time. Well, my code's just for me. Why should I not be using Eval and Exec in code that I'm writing for my test or whatever? And the difficulty with this view is, I mean, number one, if it's truly for you alone and it's not a security risk, and could not conceivably be a security risk, then who am I to tell you what to do on your machine? But consider this. I have heard that phrase, I'm not writing this for anyone else to use. Or another one is, this is just a temporary piece of code. This is just for the prototype. Those phrases, I have heard those about code which was used for years afterwards. I have heard that about code which ended up in production. I have heard that about code which I no longer know who the author is, because it had been passed around so many times. And I have heard that about code where I have seen evals used inside it. And that's the problem, is there's nothing so permanent as a temporary solution. And yeah, for some people that's true. I remember when I made the MATLAB code for this exact tutorial, so this is the second time I've done this tutorial, I wrote, I mentioned that maybe if you're using this in your PhD, in fact, this exact use case, you're using this in your PhD, you've got a whole bunch of graph code, and you want to be able to reformat this after the fact. So you've got a formatting string which sets fonts and things like that in your graph code. Like, that is a perfect use case for what I'm showing on screen. Like, very literally, my thesis was set up so I could regenerate all of my graphs end to end. And in principle, I could have had code for doing things like adding labels of different sizes and stuff like that built in. Perfect use case for this. And why would I expect anyone else to ever use that code? I certainly didn't when I wrote the MATLAB example, except thinking about it today, that code was reused. In fact, that code I think has been shared with outside parties even. So code which I thought no one was ever going to use is now out of my control. And it was code just for me that no one was ever going to use and had no security ramifications, which my name is attached to, and I no longer know where it is or what it's being used for. So yeah, just for me, except definitely not just for me, and used by other people, and out of my control now, and attached to my reputation even. So that's delightful now that I'm talking about this out loud. Well, crap. This function, so secure. This function, not secure at all. And I would not touch it with a 10